In this section, we're going to learn how to make probability statements using relative frequency distribution tables for univariate data. Let's assume that we have access to a huge database that has most of the information about the past students. Let's imagine that we requested the data and received the following frequency distribution table for a random 100 students. We already know that the frequencies can be interpreted as probabilities, so we turned it into the relative frequency distribution table. We have an intuition now that the relative frequencies can and should be interpreted as probabilities, but we also know that in order to find the probability, we must have a well-defined event, which is defined for some experiment with its sample space. So the question that we need to answer next is, what is the experiment? What are the simple outcomes? What is the sample space? And what kind of events we can find the probabilities of when such frequency distribution table is given. First, let's define the experiment. In this case, the experiment consists of randomly selecting one of the 100 students from the sample. Next, we need to figure out what are the simple outcomes. Based on the formatting of the table, there are 4 simple outcomes: 0 to 2 to 4, 4 to 6, and 6 plus. We label them Y1, Y2, Y3, and Y4. And these 4 outcomes form the sample space for the experiment. We describe the outcome Y1 as an outcome in which the randomly selected student spent between 0 and 2 years in college. We describe the outcome Y2 as an outcome in which the randomly selected student spent between 2 and 4 years in college. Hopefully it is clear now how the simple outcomes are defined. Now that we define the simple outcomes, we can interpret the relative frequencies as the probabilities. For example, 0.27 is the probability of Y1, 0.42 is the probability of Y2, and so on. It is worth noting that this experiment doesn't have equally likely outcomes. Now that we understand the experiment and its simple outcomes that form the sample space, we can start defining different events. Before we do that, let's draw the Venn diagram that includes the 4 simple outcomes. Let A be an event in which a randomly selected student spent 0 to 4 years in college. As the Venn diagram suggests, the event A is made of the 2 outcomes, Y1 and Y2, so its probability is 0.27 plus 0.42 equals 0.49. Let B be an event in which a randomly selected student spent between 2 and 6 years in college. As the Venn diagram suggests, the event B is made of the 2 outcomes, Y2 and Y3, so its probability is 0.42 plus 0.20, which is 0.62. Let C be the complement of A. As the Venn diagram suggests, the event C is made of the 2 outcomes, Y3 and Y4, so its probability is equal to 0.20 plus 0.11, which is equal to 0.31. We can also obtain the same result by using the complementary rule. Let D be the intersection of A and B. As the Venn diagram suggests, the event D is made of only one outcome, Y2, so its probability is equal to 0.42. Let E be the union of A and B. As the Venn diagram suggests, the event E is made of 3 outcomes, Y1, Y2, and Y3, so its probability is equal to the sum of 0.27, 0.42, and 0.20, which is equal to 0.89. We can also obtain the same result by using the general addition rule in the following way. We discussed how to use the frequency distribution tables to produce the probability statements about the events and compound events that are properly defined in the context of the given frequency distribution table.